to the cloud. So now we're recording. Where you will be able to find them. This first week is going to be a little weird. It's on YouTube where I post them to. You're in Slack? Okay, so just send me a message on Slack. I'm Stephen Welberg ET, so like on direct message, there should be a little plus, and then type in Stephen Welberg there. Send me a little DM. Just say hello. I have a little dumb thing there. Yeah, look at that. People starting to come in, sending me the DMs. Okay. Yes, you can see all the videos I watch. But so yeah, find me, Stephen Welberg. And one of the playlists will be, oh, and I actually have playlists from last semester. So that's kind of cool. Why is the liked video a playlist private? I guess, whatever. So COP 3502 Fall 2020 Lab. You might be able to use this. Oh, it's probably not the most organized. I'm also TA programming too, and I'm trying to fix that organizational structure. Oh, you get to see this beautiful. Okay, but so find this and you can find that, find my account, and it's just one of the playlists that I have, Stephen Welberg. Also, if during the week you don't have this, my email and YouTube account, you can just DM me on Slack and be like, hey, give me the playlist. And I'll be like, okay, here it is. Because by tomorrow, maybe Wednesday, it should be available on my account. And honestly, by tomorrow, if you DM me for it, I'll just upload it right then and there if I haven't yet, because I could be able to do it by then. But you definitely need to DM me on Slack right now. Like, I'm going to wait for everyone to DM me on Slack. So DM me on Slack. That we're pulling the teacher waits until everyone in class participates bowl, where you need to DM me on Slack. So let me just add a little, open up my attendance slide. I'm gonna put a little thing here. Well, that is mine. But how do you join the other ones? If you don't see all the channels, the only one you won't be able to join is the COP 3502 TA one. But all the other channels, you do channels, the little plus button, browse channels, and then there's all the channels, and you can join all the ones there. Okay. So Ernesto asked the question, how do you join a channel? So I just walked him through how to do that, and that's how you do there. You can also have it in your phone. That's fine. Oh, but Evan, okay, so Evan asked, how do I DM you? But you already did that, so I'm not gonna, yeah. So how do you DM me? On desktop, there's the direct messages and a little plus, and then you type in my name. On the phone, on my iPhone at least, on my phone, the thing looks almost exactly the same. If you're already in a channel, then you have to click like the top left to back out, but there's a direct message and then click the plus button and then you type my name. Oh, you figured that out, Evan. You got it. It's asking for your UF email. Yes. For joining, it's because it's like a UF affiliated Slack. UF is with Slack, I think, or something. If you don't have a UF email, I don't know what that one I don't know. But let me. Danielle, do you not have a UF email?
No, I have it. It's asking for your email though, like to invite people in. I click plus under like direct messages, and it says to name at ufl.edu. So I'm assuming I send you an invite.
No.
Okay.
So if you the direct message, click the plus, and at the top, do you not see a 2? And then you just said you see a 2, but then you start typing my name.
Okay. Direct message plus. Oh, okay, I think I got it.
Okay.
All right, thank you.
No problem. I did get your message. Yes, Ernesto, right there. Yes, I see your message. Yes, we're good. But that is if ever you guys no longer have, not no longer, but now you know where to find me if you have a question. this is how you do it. So make sure you remember what the process was to do that. Because if you don't know how to do that, then you want to ask me how to do it. Well, this is how you'd ask me how to do it. So it's kind of a catch-22 in that sense. But yep, got you, Jed, Evan, Ernesto, yes, Kyle, John, are you JC? Gotcha. You're good. Stuart, Camber. And do we still not have Mayor? Still don't have Mayor. That's fine. Let's see if they're already on this line. Mayor. Is that it? I'll figure it out after lab. That's an after lab kind of thing. Okay. So awesome. I'm assuming all of y'all just send the hey, didn't send me like private information, no social security numbers. Okay, cool. Awesome. Got everyone to Slack me. Great. So yes, that if you have any questions, want any files, that is where you send me those questions. Next thing we're going to do, make sure you've installed your IDE. Theoretically, hopefully, I pray that all of you have already installed an IDE and have run a Hello World program. Yes? Yes. Awesome. Okay. Is everyone else in? What library? Okay, you didn't do that. I'll kind of walk through some stuff. Well, definitely, I would highly recommend using IntelliJ just because that's what all the TAs are going to be able to help you with. If you can use Eclipse, you should be able to work. Well, with IntelliJ, if you have it set up, it might. I might have to have you share your screen if you need help setting that up. So you might need to join the Zoom, but just try doing it by yourself first, and we'll see where it goes. With IntelliJ, I know I got a bunch of yeses, so that one I'm not checking to make sure everyone sent me a yes on that. That's fine. I personally use Community Edition. There's not really a difference. Ernesto asked what edition of IntelliJ you need, and you can have Education or Student Edition. That's fine. But just open it up. Start this like right now. Make sure that we're all on the same page. So you can try to, if you don't, because if you run it on Eclipse, you should be fine. So open it up, and then it should open like. Maybe if I close it, it'll open something different. Oh, now it's going to take a hot minute. That was a mistake. Why? Sure. If you know what you're doing, you can use Eclipse and copy it over later. That's fine, as long as you're working in Java files. Ernesto asked if he can use another IDE, and technically that's fine. But if you have a question for a TA about your IDE, we probably won't be able to help. So that's like the stipulation with that if you're not using IntelliJ. Oh God, now it's dying. I said it was gonna die, and it's dying. Yes, I'm sure I want to quit. Oh, it's because it was asking if whatever. We're gonna open it back up again. So just do it with me real quick. Oh, it's gonna open up the old thing. Whatever. Do it with me where you do File, New Project. I don't care what you name the project. This is going to be a really straightforward. And this, you are going to have to do this because I'm going to have you submit it to Zybooks. So lab 1 on Zybooks. What is lab 1 called? Because that's important because you need to know what the lab is called in order to submit on Zybooks. So on Zybooks. Okay. I'm just going to open up there because just to show everyone where I find it. So the name of the lab, you need to see this because this name right here is what yours needs to be named. So in this case, it's hello.java. So, what's up, Ernesto? Of the project? So Ernesto asked if this is the name of the project. The name of the lab is just hello right here, but this is the name that your Java file is going to need to be. So the name of your project doesn't matter. So if we keep going, Just click next through all this. The name of your project and also the location of the project, that doesn't matter. You can call it whatever you want. Project 1, that's fine. Or untitled, that's fine. I'm gonna put it in code. Okay. Oh, it's gonna, got it. I understand what's asking now. Whatever. So wherever you put it, whatever you want to call your project, that's not important. What is important, well, it's important for your structure. What is important is when you're actually setting it up. So we're right here, right-click SRC folder, new Java class. Here's where it's important. And so this right here, your class needs to be called what this is called. So in this case, it's hello. The .java gets added. That's what class files are called. So put in hello right there. And then I think it's just enter. Yeah, enter. There you go. So we got this public class hello, and you'll see that it made this file hello.java. So that's the really important part, is to make sure that your hello.java is called hello.java so that you can submit it properly. If you don't, you can't do that. What's up, Ernesto? Public class. Yeah. And then from here, we're going to do a super basic hello world code. To set that up, I'll give you like a couple extra seconds just to get there. But to set that up, we're going to make a main. And a main function is required as a starting point for the code to begin. So code is a list of instructions that your program executes, and there has to be a main for it to start somewhere. To write that, our short script in IntelliJ, you can just type out main and then tab. And this is a super standard main function. I don't think I've ever written a main function that doesn't look like this. So that's why that's like a shortcut for that. This is not a constructor. This is main, yes. So Ernesto asked if this is a constructor. We'll get in constructors more when we talk about classes, but that's not for a while. But this is the main function. And so this, for these first 3 projects, I think you really only need a main function. Yeah, I don't think you really only need a main. So if you know programming and you know how to write stuff, that's totally fine. But for this first time, we're super basic, we just need this main function. So to start off with the hello world program, you just put system.out.println here, and I'll zoom in. System.out.print or println, that's not important. And then put a semicolon at the end of it, and inside put hello world. What you put inside these quotes doesn't matter, but there you go. What we just did here is you got main, this is the starting point, and then this is the first command. This is saying go to the system output, and so system is just generally your system, and then the output is whatever you're printing information to. So in this case, it's going to be a terminal when we run it, and we'll run it in a second. And we're saying print information to the output stream. And the information you're printing is this right here. This is called a string. It's just, it could be, you could call it a sentence, but string is the official word. And a string is a bunch of characters. Characters can be letters, numbers, symbols, whatever, inside of a string, inside of these quotation marks. So yeah, a string is a bunch of characters inside a quotation mark, and a character can be a bunch of different stuff. There's a special interaction with backslash, which we'll cover in a little bit, but just avoid using that. But yeah, anyways, once you've got this set up, the way you run it for the first time is on the left here, you'll see these green play buttons. Click the one that's to the left of your main. This is saying, yes, start this code from right here. Run hello.main. And if everything worked, you should see this. Does anyone not see that? And like I said, I'm going to have you submit this code to lab 1, because for lab, there's no limitations on submission. So you're going to submit it. I'm going to want to see that from everyone. So you don't need to say yes, but just assuming that if it doesn't work, say no. That's the important part. Doing this little plus button here, just for the record, set up this thing on the top right. So in order to run code, you need a configuration. We'll get into manipulating this in a couple later labs future on, but for now, you never need to do anything in here until we get into like command line argument stuff, but that's later. But for the first time to run it, you do the one left of main, and then for the future ones, you can just click the play button up here. You don't see the green arrows. Okay, can you share your screen and show, here, let me stop sharing. There you go. Can you share your screen and show me what you do have? You can see that. Okay, cool. Okay. Yeah. Okay. Your main, yeah. Good. Ernesto just pointed it out too. Your main is spelled wrong. There we go. It's already closed next to the main up top. You'll see it's closed right there. So yeah, now you see the green arrows and now you're good. Okay, cool. So yeah, spelling is super important. It needs to be main. It can't be something else. Main is a very standard start from here. Okay. Awesome. Okay, so I'm assuming everyone else got that right. So now that this has worked, we need to submit it to Zybooks. Obviously, this isn't actually, I mean, not obviously, but this isn't actually what we need to submit to Zybooks for Lab 1. Like, we'll have to do more stuff, but we're going to submit it right now to Zybooks. For the future, make sure to check to see if there's limited submissions, because I think for the project there is, but we'll cover that in a little bit. But so yes, to submit it, open up Zybooks, go there, go to the home. Yeah, so Ernesto, we'll cover that in a little bit, but Ernesto pointed out that there is ways to test it with unlimited submissions. But for now, like I said, we'll worry about that when we get to discussing the project later. This first week, I really want you to just focus on getting Lab 1 done, like today, working on Lab 2, getting that, since you can't submit it, you won't be able to check that it's done, but just get it working enough that you think it matches the functionality that the document I sent. Oh, and I need to send it to you. Just get it submitted. That's close enough. And then also look at Lab 3 and try to do that. Because Lab 3 has the loops you're going to need for project 1. Oh, what did I just do? There we go. No problem. Okay. There we go. Now you have it as well. Okay. So on here, going to Zybooks, yes, main thing, go to section 14. That's where the labs are. I don't know if you can see all of them yet. Actually, if you could see all of them, you might be able to submit it. Anyone let me know if they can see all of them. That one I would like. Does it auto? Can I submit and does it auto say? You can see all of them? Oh, that's really cool. So then you could actually try Lab 4 now. Then that's Lab 2 and 3. Highly recommend that. Anyways, Stewart asked, can I submit and does it auto save my work? I don't know. IntelliJ, when you run it, it'll save it. I don't know how often it auto saves if you don't run it. I personally still just Control S to save all pretty frequently. But let's go to, but for Lab 1, you can submit. So just when you're in here now, do choose on hard drive. And to find, or you can also click and drag. So we'll cover the click and drag first, because the choose on hardware might be user specific. If it's saved under a wrong name, so if you didn't save it as hello.java, like I said, it needs to match hello.java. To change it, you can't just rename it. So like if you went to the file and tried to rename it manually, like I think mine is stored here. No. ET stuff. So just a warning, I'm just going to show you the error real quick. If you try to change it here, oh, that's not, it's in whatever, isn't it? It's in, there we go. No. If you try to change it here, so let's say I renamed it to hello1, that would be an issue, because if you just change it here, then this doesn't line up. So the important part is you need to actually change this and the name. To, let's say, oh, I keep clicking random things. If you have it saved wrong, there's a really easy way to change it though. So if you like, let's say I did it hello1 and so that's incorrect. The really easy way to change it is to go to the file right here, under the src folder, right click it and say refactor. Where is that? Refactor right here, refactor and then rename. And then there you can change it to hello, refactor. I can just click enter and that will change the class name correctly and the file name. So you need to make sure you do both those steps. Okay, from there, like I said, okay, yes, dragging and dropping. So yes, I found my file, yes. In IntelliJ, if you right click the project folder and do open, show in Explorer, I think for Mac, it's like open in Finder or something, but for Windows, it's show in Explorer. Go in there, that'll take you to where it's saved. So you don't need to remember that. So just go into the project, go into the source folder, there's your file. And so from there, you can click and drag into here. If you want to find it, choose on the hard drive, then you have to know where it is. I'll show it again after I do the hardware one more time. I got you, Evan. Yeah, got it. I can do it again. I can do it slower. I'll do it as many times. We're making sure this works. It's super important. Okay, let's see, the hard way, finding it, programming one, whatever, src, hello, it's submitted. Curse for it, yes, I'm playing SevTech right now, but that's for another time. Okay, so yes, in IntelliJ, right-click the project name. I think you could also right-click the src folder. I think you can right-click even hello. Yeah, you can right-click almost at, yeah, you can right-click any of these folders, I think, and do show in Explorer. You can't close, okay, that one, I don't exactly know how to help. You clicked find in files. Okay, I'll share screen. We'll share screens in a second to do that. But anyways, click one of these things, right click, show in Explorer, and then whatever you clicked, just go into there, go into the source folder. So yeah, you should only really click whatever src or hello, because that's, if you did the out folder, show in Explorer, it would take you to something weird, so you have to back out first. Oh no, actually you didn't have to back out there, but yes. src, hello, and then drag that file over to Zywick. So you have to have like both of them open. Stuart, share your screen and I'll look at it. What do you mean you can't close it? Can you share your screen?
Yes, I'm trying to figure out which. Where is it? Yeah,
It's like the, yeah.
Yeah, I think that's it. It's like,
oh,
I was trying to
move it up. Move it.
You think I should just restart it?
No. Click open in find window on the bottom right there. Click the pin button. Okay. Click outside of it, like click back in IntelliJ.
I think that worked.
Sure. Okay. Awesome.
No sleep. Okay, yeah. All right.
And I want you to submit it. Yes, I want you to submit it right now. I'm going to go check to make sure everyone's submitted. Because this is another one of those things that everyone's going to need to do this. So I'm just making sure you can do it right now, so no one has any issues with that. Or if you do, we have a baseline of we did it right here, right now. Let's work from this. And this also helps with another aspect of I can actually see what people submit real quick. So Stuart has submitted something. John, you submitted something. Evan, you submitted something. And this shouldn't give you any errors. So if when you submit it, it gives you an error, please let me know. I'm not going to look into that. But if it gives you an error, I'll take like a look. It should give you 0 out of 0 though. 0 points is correct because it's not at all what we're trying to do today. The due date for lab 1, it's on Canvas. I think it's like next week, the 5th. Oh, that's quiz 1. Yeah, the 4th. Next week, the 4th. Well, the project 1's due on the 5th. That's why I'm also adding on the lab 2 and the lab 3. So you'll notice if you have some background, lab 1 might be really straightforward. If you don't have any background, it's still kind of straightforward, but we'll have to work through some stuff. But yeah, it's really easy. So I really want you guys to try working on lab 2 and lab 3. Jed, make sure you get on that submission. So you don't have it running on Eclipse yet?
Yeah, I got it here, but I mean, I'm going to submit it today when I download the JDK library for IntelliJ.
Okay, that's fine. Cool. But if it works on Eclipse, you said you were going to use Eclipse.
Yeah, but I mean, I'm going to copy and paste this to IntelliJ and use IntelliJ as a submission file.
The file is the same no matter what.
So it doesn't matter if it is IntelliJ.
The thing that matters is that I can actually help you if you're working in IntelliJ if you have an issue with that. Eclipse, I can't.
But I think that they are going to, you know, to review that file using IntelliJ.
No.
Not?
No. It's going to be reviewed on Zybooks.
Oh, Scilab.
Zylabs, yes, same thing. So we were just talking about using Eclipse again. Small tangent. Okay, when the files can't close it, are you sure you want to submit? Hey, did you name it hello in the beginning with the SRC? Yes, I did, Jed. I did name it hello in the beginning. So yeah, I said you've got to find what it's called here, and that's what you need to name it. If you didn't name it correctly, there is a way to fix that still. I'll walk through it a second, but I can do it again if I can. There we go. So yeah, Jed, if you named it incorrectly in your SRC folder, the file, you can right click it and then refactor and then rename. And then you can name it hello again. It's already called hello, so I can't do that, but that's where you change it. Do you need help with that? We can share your screen and work through that real quick. Fancy, thanks. It's all a Java compiler, so it works. Okay, so you're gonna worry about later. That's fine. Cool. So now we got submitted on Zybooks. Last thing, this isn't a now situation because Honorlock takes a hot second. I did say today, but it's not in lab today. This class is using Honorlock, I'm fairly certain. You should have access to like the Honorlock practice quiz, and if you tried to go to quiz 1, it should tell you to use Honorlock. So do the Honorlock practice quiz today. Make sure you can do that. You're gonna have to take quiz 1 either today or tomorrow. So just get that installed. If you have any issues with that, I don't really know if I can help you. They kind of walk you through it. on here. If you have any issues, you have to like contact their support, but I might be able to help. So if you have any issues, you might be able to DM me your question. Or is it lockdown? I don't know. I don't know. She has a lot of stuff on the Canvas site that I can see too much stuff. I don't know what you guys can see. But just try to take, like, when you first go to the quiz, see what it tells you to do, because it'll tell you if you need either honor lock or lockdown, and do whatever it tells you to do. Me? Yes. Yes. Okay. Cool. So that's all the stuff that I wanted to get done right now. This week I kind of talked about it. I'm going to add the lab 2 and lab 3, but those don't have due dates. So yeah, read Zybooks chapter 2 for the quiz. I don't know if it's needed for the quiz, but it's part of this week and the quiz is due today. So I don't really know the order of her topics on that. Actually, I don't think quiz chapter 2 is for today. I technically don't think it is, but still read it, then take the quiz, get lab 1 today. So it's a lot of stuff today, tomorrow. If you're really busy, maybe you can push doing the lab, but the lab should take you just today. We'll go over the next step of it after outputting, because it's outputting and inputting. That's all it really is. But then lab 2 and lab 2, you could probably take some more time with, especially since we won't be going over everything in there. We'll be going over a fair bit. And in lab 3, I'm not expecting you to do lab 3. Just saying that I got tired. Like lab 2, I do expect you to get that done before next lab period. I know that's a lot, but you're gonna have the project due the next day, so you will need to have gotten this done. Lab 3, you'll also need to have gotten like a fair bit of it done in order to, like, if you can't do a little bit of lab 3, then it's probably not the best for project 1. So we're gonna make sure we do that. Yes, so that's that. Now let's actually go over lab 1. We got a chat. Yes, this discussion is only Mondays. I think she also limited the discussion for her thing. So this Monday, I'll be trying to cover as much of lab 1 and lab 2 and maybe touch on lab 3 a little bit. I'll also be going over some loop stuff like that. I'll definitely make sure I get to, even if it's not in context of lab 3, because that's what like this week is about. And then next week on the 1st, then I'll try to go over all of lab 3 and then a lot of project 1. So try to get like as much knowledge into as possible. But yeah, so we have our discussion meetings just this Monday once a week. Okay. So project 1 specification is the stuff that is not bolded is stuff you output. The stuff that is bolded is user input. So this, like, it's really straightforward. Here's some examples. You output, hello, what is your name? They input, Jimmy Dean. Then you have to output, it's nice to meet you, Jimmy Dean. How old are you? And then they give a number and say, I still, you're quite young, only 18. So there is that whole, you're quite young at 42. Where's that line at? Oh, it's all quite young. Okay, so there's no change there. It just says you're still quite young at only whatever they inputted. Where do you live? Input. Wow, I've always wanted to go to that, whatever they inputted. Thank you for chatting with me. Bye. So it is print something, input, print something using the input, and then get more input, and then again print something using input. Like, just keep printing and getting input. So we've already slightly covered printing something. Yes. Yes, that was just said. So I'm going to go over to my other one. Oh, come on, don't be a pain. So hopefully you've got your like your hello.java file. We did all the stuff. Actually, we could just use the one we used a second ago. I don't know why I did that, but come on, there it goes. So we covered printing out stuff. So in this case, it's printing out, hello, what is your name? So I'm just going to write that right now. System dot out dot print. Hello, what is your name? And I might have gotten, like there's a period there. So I got the formatting wrong. Try your best to get the exact formatting of the strings correctly. But when you submit on Zybooks, like all of you just submitted a second ago, Jed, I'm going to use you again. Oh, Jed, you still haven't printed. Jed, I trusted you. Evan. Okay, so Evan, you submitted this. It tells you what the difference is between your output and the expected output. So in this case, it actually, so blank white space doesn't count. So spaces are fine if you have weird spacing. So that's why there's not like a new line character there, which is just a little weird. But you can see the exact syntax that they're looking for if you mess up like a period or something. But anyways, if we've got this right here and print it out, it's gonna load. We just did, because I ran the wrong file. Run. Don't have multiple files in your projects to start. That makes it a little more complicated. But with just the one file, assuming you just had the one, not changing things up, just hello, what is your name? So that is the first part of this lab. That is just a little bit more advanced hello world. The next part, getting user input, involves using a concept called a scanner. So I don't think we have access to it. So a scanner, you write it like this. I'm actually going to put it above. Here we go, scanner. Yeah, okay. So you don't actually, if you just try to type in scanner right here, input new scanner system.in. I'll cover the other stuff I just wrote in a second. But if you tried to write a scanner, it wouldn't work. So you'll see IntelliJ is like, did you mean java.util.scanner? Alt enter. So if I do alt enter, it'll give me some options to fix the issue. And right here, this fixed the issue. It's because to use the scanner to get access to it, you have to import java.util.scanner. That's saying, give me what is in that file so that I can use it. The library? Oh, I don't know where that comes from, to be honest. Sure, that's fine. But so yeah, you just say, I want access to this code. And so now you can actually use it. A little shorthand you can do is java.util star, because java.util has a bunch of things in it. So if you just did java.util dot, you'd see it has all these things. And some of these things are not useful. You don't need them. But java.util has a lot of useful stuff in it, like scanners and arrays and linked lists. And so if we don't want to have to manually type out all of those, you can just do java.util.star. The downside of doing this is that technically it's more code to compile, so that can be an issue. Can you zoom in a little? Yes, I can. That's an easy fix. There we go. So that's just a quick shorthand. And if you're not doing that too much, it definitely won't impact your speed almost at all. But this is a really simple one since util is very universally useful. So yeah, now you can actually make this scanner. And in setting up the scanner, you do object name, variable name equals an instance of the object. So you might have, in your readings in the past week, you might have seen something like int x equals 2. there's a correlation, like you should see some patterns between this and what I just put right here. So int is the object type scanner, x is the variable name, equals an instance of the object. So this is how you make an instance of the object, you new scanner. And then in here, it's the same thing as we did here, is this is system output. So this is what the terminal is. That's what this is referencing. This is referencing the terminal except getting input from the terminal. So it's kind of like the opposite of system out. So yes, keep that. And then this variable name right here can be whatever you want to call it. In X, you can call it whatever you want. I'm going to call it input just because I always call my scanners input. You should really only ever have one scanner. If you start using multiple scanners, you're going to break your program. So just if you're ever scanning things, just only have one scanner. We'll talk about loops in a little bit. You don't want to put it inside a loop, just the singular scanner. Okay, now from there, to get input from the user, you have to do input dot, and then you have access to all of these functions. So you're saying using the scanner we made, so you're saying this is the scanner we made, dot is saying using that one, run one of these functions. Now you see that there's a lot of stuff there. There's a lot of stuff. Most of the things that you're going to be concerned with have to do with this next word. So if you do input.next, these are all the really important ones for you. Maybe not has next. Yeah, we'll cover has next later. But just next. For the start, you're really only going to want to use next. That's all we're going to use for this project. But in the future, if we're trying to get numbers specifically, you might try next int. Or if you're trying to get a decimal point, you might try next double or something. We'll get into that later. But this lab, you just need next. And I'm just going to make sure that's not next line. Yes. Cool. So with doing this, now this is going to prompt the user for input. But we have to actually put this input somewhere. We want to be able to actually use the input. If you just did this, it would ask for input and not store it anywhere, and you couldn't do anything with it. To actually use this input, we store it in a variable. It's going to be stored in a variable. Next returns a string. So input.next, since it returns a string, you have to store it in a string. User input equals. You can call that whatever you want. I'm calling it user input. I'm trying to think of a better name for that or something. Or response. Sure, response. So in this way, now if they typed an input, it would be stored in this variable. And you'll see this string word. We've seen the string word before. It's up here. We're not going to worry about it, what it means in here just yet. But when I was talking about stuff inside of quotations, I was saying that is a string. So a string is the stuff inside of quotations. So even though we didn't write any quotations for this, it is stored as something like this. We could actually write this first line as string, and then again, a variable name doesn't matter, so I'm just going to do var1 equals, and if we copied and pasted this here, this would be legal. This would be good. So now this string, this collection of characters, is stored in var1. And along those lines, instead of putting these quotes in here, we could put var1 in there. So this is just using some variables. So now these two would do the same thing. And here I'll even show that. That should be an easy one to show. So if we run this, this prints out, hello, what's your name? The exact same thing that we had before. Now, back to what we were talking about with the using input.next. With this response, we're storing user input inside this variable. So if we actually, I think with running this, it should want, yeah, so running this, it actually is asking us to type something. Before I had it commented out, but now it's asking us to type something. So you'll see the program's not done, but I have to write something out. I just typed hello, and then the program ended. Now notice this didn't actually output hello. This was me typing hello. I know you might not be able to see that straightforward, but know that that wasn't output, that was input. You can tell by the different color on here. If we wanted to actually output it, we would do something very similar to what we did right here. Just do system.out.println response. And on IntelliJ, you'll notice that this even didn't this ungrayed out itself, so it's saying that it's being used. So now it's being used, and we run it. There we go. So now I typed hello on here. I'll zoom in on this because I know the other one was small. Typed hello, printed hello. It's great. The last concept I'm going to cover for this, because you can just keep doing this over and over again if you wanted to. If I just copy and paste this. Oh, don't need that. Copy paste this one more time. And you'll notice that it's red underneath this response. The reason is, even though I copied and pasted it, and so hopefully you would think it would do the exact same thing, the one difference is that the variable response is already, this is called initialized. Initializing a variable involves giving it a data type. And so since response already has a data type and has been initialized, doing this is an error called reinitialization, and you're not allowed to do that. You can reassign it to something, but you can't reinitialize it. And so to not reinitialize it, but instead reassign it to something, you just delete that string part. And so now this isn't initialization, this is assigning the already made variable response to here. So in this case, we run it, it's just going to do the same thing 3 times in a row. Types it out. I could type something different, so it's not the same thing. So there you go. It's asked for input and then prints it out 3 times in a row. The last concept I'm going to cover with this, and then I'll take some questions if y'all are confused about how to apply that to do lab 1, is with this here, I'm actually going to do, I'll just use what I have here. With this, I'm going to do var1 plus, and then var1 plus var1, actually no response. So when I set it up like this, so right here, this first couple is going to work exactly like we've talked about before. But right here, instead of just printing out response, it's going to print out both what I stored in var1 and what's stored in response right next to each other. No spaces. Right here, maybe if I wanted to add a space. So now it'd be the value stored in var1, which is this string, plus an empty string, so that now there's a space there, plus response and then response again. So if I run this, I'm gonna actually zoom in again. Steven screams name. So you'll see I did this, it outputted it like normal. I put scream, it did hello, what's your name? And then it printed out scream, no spaces, because I didn't put one. Because there's no space character in either of those strings at the end or beginning of scream. And then name, what is your name? And then I did space, name, and then no space, another name. So that's how you can combine strings together. With that knowledge, you should be able to do lab 1. Any questions on that? Any parts you want me to repeat? This is the real lab 1 assignment. Yes, you can. Yes, this is what you have to do. Submit it to Zybox. Yes. Okay. Now on to lab 2. So again, you can't see it on Canvas yet, but I sent it to you through Zoom. Lab 2 now goes into some mathematics. And we're also have to store numbers. I don't think you have to do error handling. Just reading over it real quick. Ooh, if it's not about, okay. Okay, what am I gonna do to help talk you through that? The input is an invalid integer, it should print. I don't think we're going to give you anything but an integer. If that's a lie, then I'll be sad. But okay, so this is applying what we just talked about, taking user input, but now we're going to do a couple extra steps. Right here, the enter first operand, instead of getting user input that's a string, we're going to get user input that is, right here, it's called a double precision floating point value. That's just called a double. So the input, instead of being a string, is going to be a double. And you're going to get two strings, two doubles, store them, and then based upon the selection they do right here, do some sort of math to it. So in this case, they did, what operation do you want to perform on these things? They selected 4, 4 is division, and then print out the result. So the couple of new different things, first off, getting user input that isn't a string, that goes into the new next stuff. And then also you can check like what it needs to be on Zybooks. On Zybooks, technically it needs to be calculated at Java, but again, since you can't submit this just yet, that it probably isn't the most important thing to worry about, but I'll worry about it. Copy and paste, source, new Java class, calculator, class. The setup is still the exact same. You made a calculator class, you do a main, still need a main. Now's where the different stuff comes in. So we're going to need to get user input. So we're going to need that scanner. So we're going to need to import java.util. And then star. And then again, you can set up the scanner however you want. It's a different file, so it could be called something different. I'm just going to call it in here. There we go. So this is a pretty good straightforward setup. If you create a file with the right name, and if you need to get user input, you're going to need a scanner. So super straightforward setup. So from here, getting that correct user input. So I don't know what I'm supposed to ask, so I'm just going to put something here. Give me a double. Getting a shot here. Okay. So to get a double, first thing, and before the setup we had, I think it was like this, response equals in.next. So this was our setup before. This was taking in a string using the .next function. Now we're taking in a double using the in.next. And if we start in from beginning, there we go. In.next double. And actually, as you were typing .next, it was like, hey, this is the function that's going to return a double. Do you want this? So you can just click tab as it's completing, or you could just manually type out the whole thing, double. So this is how we get a number from the user input instead of a string. So you need to do that twice. You're going to do that twice. And then you're going to need to print out, oh, too big, too small. Just right, okay. Then you're going to need to print out this menu. There's nothing crazy about it. It's just a long thing. You can do multiple print lines just to print this out. You can copy and paste it from this lab book. That's totally up to you how you want to handle that. But that, like, there isn't anything crazy with that. The crazy part comes from which operation do you want to perform? I'm actually going to check real quick that we don't give you anything besides. Oh, oh, crap. I'll cut that from the recording. Yeah, I'm going to have to do that. This is why I didn't want to look at it. Okay. Integer, 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 integer. Okay. Yes. The only thing we give you, I'm just going to close this. The only thing we give you as input for the last thing right here is an integer. So if there was a chance we didn't give you that, then I'd have to go into more details for stuff. But this is definitely going to be an integer. So if you can imagine what we're going to do here, ooh, important note on that, since response is a double, we can't store an integer in there. So maybe in this one, it might be good to do like response double. But now to store an integer, it's the same pattern. You should really notice a lot of patterns in programming as you go. In.next. Oh, response int. That's what I meant. Int. Also, this shouldn't double. There. Oh my God. What the hell? In.next. Okay, there we go. Yeah, so it's a lowercase double. I don't know what uppercase double is doing, and that should have given me an error. But yeah, lowercase double for that. So a scanner and string were all uppercase, but primitives, which is like int, double, character, are lowercase like that. But yeah, response.next int equals in.next int. So you can see that same pattern right there with how to get that input. So Ernesto just asked if we're allowed to use floats. No, because in the lab doc, we are saying specifically read a double precision floating point value. So since we specified that, makes you have to do a double just to make sure your math ends up properly, because that could be an issue. The difference between a double and a float is just the amount of decimal place it can store. So technically the difference is they can only store a certain number of digits. So the difference is the number of digits they can store. But when it's really small numbers, then it's basically the number of decimals they can store. But if you're working with really big numbers, like in the billions, then it couldn't store as many decimals. So it's the number of digits. But yeah, double can store twice the amount of digits. So that can technically affect the math. So make sure you do sort as a double and not a float. So there we go. This is mad because it's never used. That's fine. But so yeah, this is how you get that input. So with that knowledge, you should be able to do this and this. So here's an example. So you should be able to do all of this first part. I'm having trouble with opening up new files. Cam, what's your issue with, like, what specifically is the issue with opening new files? Like creating a new one? To create a new file, you could make a new project. That's what I'd probably recommend for you guys. So just like the whole new project setup. If you want all your files in the same place though, which is fine, for like really simple one file things, which is what you'll see me do. New Java class, and then type in the name of it. I typed calculator, but just type in new file, sure. So is that not working for you? Right-clicking src, new Java class? All good now. Okay, perfect. So yeah, with all that, you should be able to do all this. Now we need to actually use the input though. So all that prep work, you just store it in files. Obviously we didn't do, technically you should probably have like, maybe since you're gonna need to store both of these things, you might not wanna put it in one variable, but you can make another double variable and just set it equal to that as well. So it'd be like response, or now you don't need to do response since it's actually something specific. First operand, I think is probably what those are called, operand, and second operand or something, whatever you want to call it. Whatever you want to call it. Ernesto was saying you call it operand one, just variable names can be whatever you want. But since you're gonna need to keep track of this and this and this, you're gonna need at least 3 variables to do that. In lab 1, we were only dealing with one thing at a time because it was James Brown, 42, Magic Land. There was no reference to anything previously. In the next one, you only need the one variable. So now we're going to need multiple variables. So you're going to probably need at least 3. I won't write out all 3, but you're going to need 3. But with all 3 of those variables, now we have to actually do something. And that's where if and switch statements come in. I think in the lectures, she's already talked about them. So I'll do like an overview of them. And then if anyone has any questions about the overview, I can go in depth into certain parts. But Canberra, I'm going to mute you. Oh, no, you got cool. Okay, so if statements. If statements are the super bare bone. I've never seen a programming language that doesn't have an if statement thing. So what you do, yes, I'll get to that. So what you do, this is the basic setup. And then inside this parentheses here, you put something that will result to either a true value or a false value. Yes, Ernesto points out that that is a Boolean, but it will result to a true and false value, and we'll get to definitions and stuff like that in a bit. So yeah, whatever you put in there has to be true or false. You've seen in math classes, like calc, probably even like algebra, people have put like x, here, I'm gonna do like 5 is less than x is less than 10. What value could x be? Like, just give me a random one. And so you could say like 7, and that would be, what'd you say? 7. So 7, that would be true. So if x was 7, this would be a true statement. In math, what you're doing is like, what's the range of x? So you would only give a range. In programming, x can be anything, and then this results to either a true statement or a false statement. And neither of those are a bad thing. So if x was 0, this would be false, and that's okay. It would just result to false. So that's like a different mindset you have to be in than for math. Don't think of something as like logically correct or logically like things can be false and still what you do something you want them to do. In our case, we're going to be using equals. So you've seen equals in math. If you did like x equals 2x plus 10, is this a thing? Maybe subtract 2x from both sides, so x would be like negative 10 or something. That sure? Or oh, that's 50. There we go. So you'd see something like this and be like, what is x? So again, you're like trying to solve for x. You're not trying, in this case, this wouldn't be a programming thing at all. Technically, you could write something like, oh, stop. You could write x equals, I'm trying to think of like dividing. So it'd be like 5 plus 25 or something like that. That's probably not the same thing, but this way it would assign x to these values. That's something you've seen in programming. However, the equal sign, so this equal sign is the assignment operator. That doesn't correlate really well to this. Yes, then. Yeah, Ernesto is clarifying that it's like storing something. That is exactly what the assignment operator does. What we want here to get something that's similar to this, that gets closer, is this double equal sign. So now we go back to that true and false concept we were talking about before. So the double equal sign isn't assigning anymore. And now it's checking to see like, hey, is the left side equal to the right side? If yes, this is true. If not, this is false. So that goes back to the thing that we did with like the less than and greater than, where you're not trying to find the range. You're not trying to find the value of x. This is saying with what x is right now, is this a true statement or is this a false statement? So in our case, instead of x, we could do something like response int. And then the one key thing is because you can't do like 2x, you have to do 2 times x, and then a semicolon. And then we'd store it in a Boolean. So this Boolean store that true or false value. So just like we've set it up before, why is it not happy? Can it resolve symbol response? There's this typo in here. There we go. There we go. So this right here, I'm going to put it in brackets. There we go. This right here would be how you'd store that true or false value inside a variable. You store it inside a Boolean. A Boolean is either true or false. It only has those two things. It can't be a number. It can't be like 20. Some languages implement it as 0 or 1. Java does not. It is only true or false. So if you wanted to just write true or false, you would do like var 1 equals true, or Boolean var 1 2 equals false. So you could initialize them to true or false like this, but also expressions such as this one right here evaluate into true or false depending on what response int is at this time. So does that make sense, that difference between math and what we're doing and the difference between the double equal sign and the equal sign? Anyone have questions on that concept? I'll go into how to use it in an if statement, but I just wanted to cover that real quick. Okay. So now to how to actually use it. In our case, we were told that we need to check to see if it's a valid operation or if the input is an invalid integer. In our case, a valid integer would be 1, 2, 3, or 4. So at some point, you're going to have whatever you call it, response int, it's fine, double equal sign 1, and semicolon as well. Response int, double equal sign 2. You're going to have all of that for 1, 2, 3, and 4, just to like check at some point. But where you put these checks is inside this if statement. So we're going to start with just the first one. So you do if response int equals 1. Oh, why is it mad at if? Oh, because it's empty. That's fine. So that is how you say if response int equals 1, then do the lines of code that are inside this body. In our case, there's nothing there, but you could put whatever you want. I'm just going to put an output statement. Response is, needs to be in quotes. Response is 1. And that doesn't need to be in quotes, it needed to be a string. And so what I was typing wasn't going to evaluate to a string. So that's a string. And so in this case, if I ran this, what is it getting a double and then an int? So the first thing I type in, the first input I give it isn't going to be useful. So 1.3, not useful. Oh, I'm not running the right thing. So yeah, multiple files can get a little tricky. But just the first time you have to click the play button here, and the rest you can just select it from here. But calculator, rerun, stop and rerun. Giving it a double. It's not asking, maybe I should have put like, give me an int. So if I rerun this, I'll zoom in so you can see it better. Give me a double, so I'm putting in a double. Give me an int. And so here, if I type in 1, it'll assign 1 to response int. If I press enter, it'll go through this. So var1 is response int times 2, which is 2 plus 10 is 12. 12 does not equal 50. So var will be false. Var1 will be true. Var2 will be false. But we're not doing anything with those. So that's not super important. But when it gets to here, it'll say, is response int equal to 1? And if that's true, print out response is 1. So I'm going to press enter. Response is 1. If I run it again, do the exact same thing. Zoom in so you can see it. 2.3, that doesn't matter. Give me an int. If I do 5, it won't print out anything because response int was not 1. Now, what if I wanted to print out response int equals 1 when it's 1, but then something else, if it's anything else, if it's literally anything else, I wanted to print out something different. That's where an else statement comes in. So an else statement is just saying, if this is true, do what's going on in here. So if I check to see if response is equal to 1, if that's accurate, then run what's in here. If it's not, however, go to this else statement and run what's in this block of code. These two things can't happen in the same program. Well, they could if you're doing a loop. We'll get to loops later. But these two things don't happen at the same time. So if it runs within this if statement, it won't run within this else statement. So in this case, I'm going to do some dot out dot print line response is not 1. Super straightforward. Run it. Give a random double to begin with, and then 5. Response is not 1. So that's this sounds a lot like English because technically the goal of a high level programming language is to make it easier for humans to read what's going on and understand what's happening. So this hopefully makes sense as you say, if this thing, then do this. Else, if it's not that thing, do this. That should be pretty logically straightforward. If it's not, that's fine. It's totally fine. But the goal is that it's understandable to humans. So last but not least is the else if statement. We have if, we have else. There's a third thing called the else if statement. I personally like to write my else if statements like this. That's up to you. White space doesn't matter in programming, in Java. It doesn't certain languages, but not Java. So I personally like to write it like this. But this is saying, if this is true, run this, else, so if this is not true, then check this. And if this is true, do what's here. If this also isn't true, then run this. So in this case, in here, I'm going to put response int equal to 20 or 10, 20, sure, there, whatever my hands decide to type. Double equal sign. Yes, okay, so putting a single equal sign instead of a double equal sign is a super common error. I've done it like a bajillion times, but it's still important to understand the difference. And so if you see it, you can make that quick change. So here I put response equal to 20, system.out.println, response is 20 or 21 or 20. So the else, this is an else if chain. So this is saying check this first. If it's not true, check this one. If that's not true, then run this. So it's just a whole chain of checking one after another. Again, like I said before with the if else statement, only one of these things can run. Since it's a chain of if else statements, only one of them can run. If you instead do something like this, I've seen this pretty commonly. If you did this is not an if else chain. This makes it very different. Obviously, response int couldn't be 1 and 20, but like let's say in here, I did response int equals 20. If I decided to do that, this would be weird behavior, but you can. This, what it would do is if I typed in 1, it would check to see if it's true. It is. Print this out, assign response int to 20, then it'd be done with this if statement. Then it would check this if statement. Since there isn't an else here, it's not connected to this first one. So these are completely different, separate. And so then it would check to see if this is true. If it is, it would run it, which it will be now since this changes. If this is 1, then it will change it. And then if this is not true, it would run this. So it's like a whole, you have to make sure you understand if it's a whole chain or if it's just if statements. Both of them have their purposes. So you could just have a singular if statement and then an if else statement. Like that sometimes is what you need. Sometimes you need the if else chain. Else. So now everything's connected, even though there's spaces here, spaces don't matter, but it's all connected. So just make sure you understand the difference in when to use them. In this lab, you could probably get away with just if statements because you probably wouldn't assign the response to another number. But I still recommend if it should be an if else chain, you make it an if else chain. So yeah, checking that. And then yes, instead of printing out something inside these else statements, you would do some sort of math. The math based upon whatever they selected. So that's the whole chain. Do the math and then have like an extra printout statement at the end. I don't know. You'll have to test it on Zyblix, but that comes later. If they do one, yeah, no, one printout stuff. So you can worry about what this prints out accurately at the end. I'll worry about that later. But for the lab 2, since we're just trying to understand if else statements this week, so we're working ahead. Just try your best to get it done. What's up?
When you said terminating program, is it necessarily any function that closes the program, or we just let that fire?
Where does it say terminate program?
The program closes itself.
Do you just mean exit?
Yeah.
Yeah, your program exit once it gets to the end of main. So once it gets to the end of main here, then it's done. No. Ernesto asked if there's a specific function that ends the program. You can just get to the end of main. There might be a specific program.
What about the scanner? Is it necessary to close the scanner?
Mm-mm. There's probably a way to, just because that would be if you had multiple scanners, you're trying to juggle that.
Is the scanner variable dot close?
But you don't need to do that. So Ernesto is asking about just like ending stuff you need to do. For super simple stuff, you can just let it reach the end of main and it'll deactivate all the things it needs to activate and it'll end the program. When we get to more advanced stuff, maybe you'll want to specifically close a scanner. That's never going to happen in this class. I don't think that's ever, actually it shouldn't, especially because we're using Zybooks. You should never open and close scanners. But maybe in a more advanced project you were doing, sure. And there might be some Java code that ends Java function ends program. That one I don't even know if that the scanners close. Okay, so exit function system.exit would close the current program. If you wanted to use that, you could to manually force it close at some point. That's up to you. But you can also just have it end when it comes to the end. So yeah, Ernesto is just talking about different ways to close it.
One more question. This is off topic. If we don't close the scanner, does memory leak happen?
Ernesto asked if you don't close the scanner, does a memory leak happen? I don't know. I'd be shocked if it does because Java handles memory leaks. You'll get more into memory management in programming too, but I'd be shocked. Okay. So any questions on how to use any of this stuff, or maybe it's applications in lab 2? I know we jumped through a lot. Hopefully you've watched some of the lectures, so all this stuff wasn't completely new. Okay. One thing I did want to hop on real quick. I mentioned it like for a millisecond a while ago. Strings are a collection of characters. Characters are a bunch of different, like it can be letters, numbers, symbols. There are certain special symbols that you can't easily show. Like if you tried to show a quotation mark in a string, it'd get mad at you because quotation marks dictate the end of the string, so you can't easily do that. Instead, we use what's called escape characters. If I just Google it, hopefully this is just a list of them. I just need a list. Here we go. Here's a list of escape characters. The general idea is things that you couldn't easily conceptually write in a string. The real important ones are backslash itself, because backslash is used to start an escape character. So to get backslash, you do backslash, backslash. And then to get single quotes, you do backslash quote, double quotes, backslash double quote. These ones you don't need to worry about. New line you should know. So in our case, we've been using print line. So print line will print out whatever you're doing, and then you do a new line character. If instead of doing this, we did, well, actually with this, we did print line and then put a dash n at the end, it would do what we did and then a new line character. So you'll see that there is now a space between where we're putting input. So you see that extra space there, that's the new line character. And then if you did print instead of print line, it'd be like what we'd had before. So it just manually adds the new line character without having to run print line. So yeah, I'll say that the ones you should know are new line, backslash, double quote, and single quote. Definitely don't need to know form feed or carriage return. Those are like really technical. Backspace and tab, you should know them, but I don't think there's ever a point that you test on them. Don't take my word on that one. But yeah, definitely need to know these bottom 3. New line is really important. And then understanding backspace and tab. Backspace I think is really weird, just because if I show you that real quick, it literally just puts a backspace. So you see I got a exclamation mark at the end. If I run this, that exclamation mark is gone. So that's a really weird one in my opinion, but don't think you need to know it, but still just a good idea. You should understand. It's because the one I really think you should be able to know is ones that you know the meaning of this, like tab, that should be something you know backspace. New line might be a little new for you, but single, double quote, and backslash you should all know. And then they're super straightforward in how they're represented because it's a slash slash or slash quote and a slash single quote slash B slash T for tab backspace. Like there isn't any confusion there. It's not like in chemistry where potassium is K or something. That's not, there's no weird thing like that. Hernando asked if these are possible to assign any of these to a variable. These are not variables, so that it doesn't work like that. Oh, assign one of these to a variable, not, okay. So you're saying, sorry, you're saying, so a string is made up of characters. To get a single character, you do this, and then I'm gonna give it another variable name. I'm horrible in my naming conventions right now, very sorry. To do a single one, you're talking about like like that. Like that. This is allowed. Yes, you can do this. So you could do single characters, and the single character is backslash n or backslash. That's legal. Does that answer your question? Okay. There's probably a way to make it useful somewhere. Sure. But that's definitely, so we're just talking about like usages right now of these backslash characters, me and Hernando. So that's definitely not going to be a thing for this, but there probably is some creative uses that you could have for assigning one of these characters to here. I think we're getting close to, we're done. So I want to make sure that I get some loop stuff in here. Yeah, this is at 11:30, so we got like 20 more minutes. Okay, so that's lab 1. Lab 2, like I said before, make sure, like lab 1, you really should be able to do today. If you can't get it done today, please DM me. I really hope, based upon like everything we've talked about, that is super, super straightforward. For lab 2, maybe it's a little harder, take a couple of days. Still DM me if you have any questions, but lab 1, you should be able to get done today. Now, lab 3. This is actually the stuff, I would say this is the stuff that you're covering today. This is about looping. So in the lab 2, you just did a single first operand, second operand. Oh, we got a chat message. All of your discussions will be with me. Yes, I am your TA unless something like, if I died, then something else would happen. I think even if I got COVID, as long as I wasn't in a hospital on a tube, pray that never happens. I probably would still just teach at home, like if I got sick. Yeah, don't say that. That's I really shouldn't. That's horrible. But if something really bad happened, I could probably teach at home. But if something really bad happened, then another TA might take over. But yes, I am your TA. Simple answer, yes. I will be the one in all of your discussions. Your discussion should only be during this period on Mondays. Yes, I'll be in this room. So if you'd like to join us in person, I'm happy to see all of your faces every week. Hopefully they won't all be as busy as this, though I think next week will. And so usually at the end, we can just have a chat, talk about new stuff. But this first and next meeting are probably a little more like, we gotta go. Wednesday, that's not me, that's Leisha. Yeah, I am only here in this lab on this Monday. Any other sections you have on 1UF are with Leisha, and I think she's turned her Wednesdays into like office hours or something. So that would be with her. You'd have to, that's all her, not me. Okay, yes, loops. So yeah, this is just one first operand, second operand, then getting this information, and then doing one thing. Now with loops, conceptually, like the way you set them up is very similar. I'm not going to make a new file for this. I will delete all of this though, just so I can get what I need. I'll leave that. So with the if statement, we had the setup. Oh, switch statements. Super quick switch statements. Make sure you read on this in Zybooks. I don't use them very often. So switch statement, what you do is you put a variable into here. So let's say I put var1 in here. So in this case, you put a variable inside of these parentheses, and then you put these squiggly braces, and then inside the squiggly braces you put case and then some sort of number. It has whatever you put here has to match the data type of this. So in that case, switch statements can't take many things, so you can't put a string there. So it only takes primitive data types like int, character, double float. The double float would also be a little bit hard to do. So really you should limit them to like integers and characters. And you do like case 5 and then case 2 and then case 3. And then there's also a default case. So in this case, you would put that, and then it would run whatever code you put underneath it. So in this case, since var1 is 2, it would go to case 2 and run what's underneath it. Now you'll notice when I said it runs what's underneath it, I did highlight more cases. Switch statements, waterfall. So in case 2, if it gets there, it'll waterfall down to the rest of them. The way you stop it to make it act really similarly to a if-else statement. So if switch statements and if-else statements can be fairly interchangeable except for this one concept, the waterfalling concept. But to make them match explicitly, we can add a break statement. And so break, technically you wouldn't need a break on the last one, but I'm gonna put one anyways, just to be explicit. Yeah, it's dupe, that's fine. What? Yeah, so Anna's talking about the break means the statement ends right there. Yes. So this is saying instead of waterfalling, now as soon as it hits it, it stops. So it doesn't go on to the next case. You can mix and match this. So if I did here, now with this, with var1 equaling case 2, it would go to case 2 and waterfall into case 3 and hit the break. So that's just like a really niche thing. Fun fact, we love to test on that. So make sure you remember the waterfalling thing, because that's a super fun one for us to make questions about on tests and quizzes and stuff. But yeah, it'll waterfall unless there's a break statement. So that's switch statements. I do want to cover loops super quickly, just so you have them in your head. So there's technically 4 loops. There's 4 loops. So there's 4 number 4 kind of loops. There's a for loop that looks like this. There's a while loop that looks like that. There's a do while loop. Oh, what the hell are you mad about? Stop while. There we go. There's a do while loop, and you're mad because you need a semicolon? I might have got that messed up. I don't use do while loops ever. And then there's a for each loop. Okay, so I'm not going to cover these last 2 just yet. I'll save that for next time. The 2 straightforward ones and that every language has is the for loop and the while loop. So maybe not every language, but very standard. So a for loop is set up into 3 parts. The first part is run at the very beginning when the for loop gets here. So run once at beginning. The next part is checked at the end. It's checked before any loop runs. So checked before each loop. And I know you can't see it, but I'm gonna move it around. So I'm gonna check run once, checked before, and then the last one is run at the end of each loop. So it's 3 parts. One is run once before any of the loops happen. The next one is checked before any of the loop, before each loop runs. And then the last one is run at the end of each loop. So the three different parts, the way they're usually assigned is int. I use I a lot just because I think it's iterator or something, or like in math, there's like the I, J, K. I do int I, and I'm going to set it equal to 0. And then check before, I'm going to say I want this loop to run 5 times. So I'm going to do I is less than 5. And then run at the end of each loop. This one, I'm going to do I equals I plus 1. So right here, I'm saying I equals 0. This is run before the loop even occurs. So this is saying create a variable I and set it equal to 0. This right here has to be evaluated into a true or false statement. That has to be true. So if I did I equals I plus 5 here, it would be mad because this doesn't evaluate into a true or false statement. It needs to evaluate into a Boolean. So I'm going to do I is less than 5. And then this right here, it just runs at the end of each code. This doesn't have to be anything. Technically, what's up? Yes, but it technically doesn't even have to if you don't want to. The first thing and the last thing don't have to exist. The only one that has to be something is the center one. Though actually it's not mad at me right now, which is not, because if technically I could set this up like, so Hernando asked if nothing's in there, is it an infinite loop? Technically no, because I could set it up like this. Yes, you could say it very similarly to the while loop, but for loops are just so like conceptually important. I'm gonna keep going. We'll get to there. Okay, so yes, this would be the same thing as what I wrote before, because this is run once before the loops even happens. This still needs to be checked every time. That has to be there. And then this is run at the end of every loop. So if you put it at the very end of this and then never put anything after it, it'd be the same. But since for loops are such like an integral concept, they have it set up like this. So this is really how you should, something similar to this should be really how you try to write all of your for loops. If you want to get more advanced and try to do something fancy with it, go for it, but that can easily lead to errors unless you know what you're doing. But so yes, this loop would run 5 times, and I is all independent up here, so there's nothing crazy going on. So it's separate right now from everything I do in here. But I could do like system.out.print I. And so if I did this, it would run it. Let me just delete all. I'm going to control X. Stop and rerun. You'll see that printed out 0, 1, 2, 3, 4. It ran 5 times. I started at 0. It went until I is less than 5. You can change this initial condition. It doesn't have to be 0. You could change this. It could be something higher. It could be something lower. If it's, for in this case, if I set it so that this is never true, it'll even say like, hey, this probably isn't what you want. This is always false. So this will never run, which can happen. Because like I said, this is run once before any loop happens. This is checked before every single loop. So it doesn't have to run what's in here if you do it, if you set it up in that way. But you can put whatever. You could also have this be a negative. So you could do I minus that. And you could then just do this while I is greater than 0. So 2, and this is run 2 times. This is run 2 times. It'd be 2 and 1, yeah. You could also make it include, we'll get there. But so yeah, you can have any sort of thing there. With, as long as this evaluates to a Boolean, you're good. You could also even put true. That would make an infinite for loop. And this is what's mad about here. One last thing that we're gonna talk about with for loops, and this is true for all loops. There's 2 statements that are key. One of them is break. We've seen that in the switch statement. What this does here is it breaks out of the for loop. So usually put this inside of like an if statement and say like, if something is true, we want this for loop to stop. And so that would stop it. So in this case, does not loop. Why doesn't it loop? Oh, it doesn't loop because it only runs once. That's fine. So if we run this, even though I put true here to make an infinite loop, it would just run once. And it would print out a singular 2, because once it hits the break, it's done. Continue is kind of not the opposite, but some people like to consider it an opposite. I'm gonna do -1 times I. Continue, oh, it even's mad at me because it's an unreachable statement. Continue, what it does is it runs the next iteration of the loop. So basically, this is like the end of the loop, but it starts over and rechecks the condition. So when it hits continue, it runs this again and then rechecks the condition. And if it's true, it runs the whole loop again. If it's not, it stops. So continue says go to the next iteration of the loop. So that's a for loop. Continue and break statements are true for all loops. So I'm going to talk about a while loop next. It is true for that. And then next week, when I get into the do while and for each loop, it's the same for those as well. So a while loop is a much simpler loop, but it does less for you. The only thing a while loop has is inside these parentheses, it must evaluate to a true or false statement. So kind of like an if statement, it's saying, if that's true, run this loop. But the while loop has the extra thing that once it gets to the end of the loop, it checks that condition again, and it'll keep running while that statement is true. So super straightforward, like it's just checking condition like an if statement. You could put, again, like we did with the for loop, you could put true in that condition, and then this while loop would never stop. So while loop does not ever complete. Again, you have the break and continue. You can put whatever you want in here. Double equal sign if there was an X out here. And then you want to make sure that you change your condition inside the, actually, sometimes you just do while true and then you break out of it. But in here you might do like X equals X minus 1. And so this case, it would, why is it mad? Oh, because I want greater than, there we go. So there you go. So now I would run 2 times. One last little tidbit in my last like 3 minutes. You have access to so many things when it comes to conditions. I didn't get into and or ors. Java, Boolean operators. There we go. So you have access to a lot more things than what we talked about. That's not all of them.
Yeah, and it's like an extension.
There we go.
And or it's like another condition that can be, satisfied.
Yeah, well,
Not 100% required, but and is required.
yes. Okay, so you have double equal sign, which is the set equal to each other. Not equal sign, which is saying check to see if the left side is not equal to the right side. So if they're not equal, then it's true, kind of the opposite of the double equal sign. And is saying both the left side and the right side have to be true. So both the left and right side have to evaluate the Booleans, or saying the left or the right side have to evaluate the Booleans. This negates a Boolean, and then those are bitwise, so we won't cover that at all. I know I just rushed through that, but you really don't need these for the first couple of assignments. You might need it for the project, but for the first couple of labs, I didn't want to cover it just yet because it takes a little more explanation to get into, and I wanted to make sure I got all that other stuff. Okay. Oh yeah, and then you have less than, greater than, less than, equals to, greater than, equal to. So you have the equal version of them as well. Okay, so I'm gonna stop sharing. I'm gonna check one thing real quick. I'm also gonna unplug that. I'm gonna check one thing, but it's like we have a minute left, so it's about time for this thing to end. But I want to make sure that I covered everything I needed to. If I didn't, I'll send out like a thing or something. I'll figure something out. So I didn't go into some of the stuff you probably covered the first week, like machine code and bytecode. So make sure you read Zybooks about that. if you add a string and an integer together, that results in a string. But if you add an integer and an integer together, it'll just add them up. So just make sure you understand how that plus interacts between strings and integers, and it makes them a string. Oh, valid variable names. Make sure you review that. I think that was also like the first chapter of Zybooks. Okay, so yeah, there's some stuff I didn't cover. I really tried to cover all the stuff for the lab. Most of the other stuff was like first week kind of things. This week I was really supposed to cover loops more, but since that wasn't for the lab due this week, I wanted to cover that stuff. So yeah, just make sure you read YouTube. With all your, you said you'll be posting this recording on YouTube, right? Yes, I'll be posting on YouTube. And actually, if I haven't, youtube.com, you guys can't see my screen anymore, that's fine. But here, I'll post the link to my playlist for Programming 1 last semester. If y'all want to see that, and I'll DM it to you, that's fine. If y'all hate my voice, then I'm so sorry, because it's still me. But there you go. You should have access to that. So that's also my account. So make sure you save that, because that's where the playlist for the lab for today will be posted as well. I'm just gonna stop recording.